On December 25th, 2021, the James Webb Telescope was launched to a point L2, nearly 1.5 kilometers from the Earth, where it orbits around the Sun with its powerful infrared cameras and gives us first-class seats to the cosmic theater with stunning views of the universe that were never before seen. One of the ways in which the James Webb Telescope is superior to its predecessor, the Hubble Telescope, is its ability to look at galaxies that are extremely faint. These are highly red-shifted galaxies that were born at the very beginning of the universe, perhaps a few million years after the Big Bang. But unlike Hubble, which uses optical and ultraviolet wavelengths, James Webb primarily looks at the universe in infrared wavelengths and with a much bigger mirror, making it a lot more powerful to capture red-shifted light. Red-shifted light is a phenomenon that occurs as the universe expands and galaxies move away from each other. Think of light as a wave. As you move towards something emitting light, you run into the wave faster than you would if you were standing still. So the wavelength appears shorter or the frequency higher. If you move away, the opposite happens. You run away from the light and the waves appear to be farther apart, which means longer wavelength and lower frequency. Here's the thing. Just about every galaxy out there looks like it's moving away from us. And we know this because the wavelength of the light from each galaxy is longer than we expect it to be. When something is shifted to a longer wavelength, it is said to be red-shifted, since red is the longest wavelength of light in the visual spectrum. The light from faraway galaxies is red-shifting faster than the light from nearby galaxies. This was the groundbreaking discovery made by Edwin Hubble in 1929, which confirmed that our universe was indeed expanding. Now that you know how redshifting works, you should know that the earliest galaxies in the universe will be redshifted the most, since they have been moving away from us for a longer time. These earliest galaxies, which would have been producing ultraviolet light, have redshifted over time to produce infrared light, which has a longer wavelength. This creates a sweet spot for the James Webb Telescope, which is extremely good at capturing infrared light, particularly in the wavelength of 0.6 to 28.3 micrometers. The redshift of any particular star or galaxy is represented by the letter Z. A redshift, or Z of 1, indicates that the light has been traveling for 7.7 billion years to reach us. A Z of 2 represents 10.3 billion years. Z of 3 represents 11.4 billion years, and so on. The higher the Z, the farther away the light source and the longer it has been traveling through space. The Hubble telescope was able to capture galaxies that had a redshift of up to 11, or Z equal 11. This is a very high redshift number, and Hubble could only detect a handful of galaxies with such a high redshift value. These are galaxies that were born around 500 million years after the Big Bang. The galaxy GN-Z11, discovered by Hubble in 2015, was the oldest and most distant known galaxy in the observable universe. It is believed to have formed around 450 million years after the Big Bang, and is currently at a staggering distance of 32 billion light-years away from us, and moving away faster and further with each passing day. GN-Z11's record of being the oldest known galaxy stood until James Webb released its iconic first pictures, including a deep field image, which opened a new era of observing galaxies with a redshift, or Z, greater than 13. The James Webb Telescope, with its ultra-powerful infrared cameras, captured stunning images of multiple galaxies with a redshift of 13 and higher, which are galaxies formed around 200 million years after the Big Bang. The new candidate for the most distant observable galaxy has been named HD1, with a redshift of 13.27, which scientists calculated to have formed just 320 million years after the Big Bang. But new studies of the James Webb images by scientists are showing some very strange observations. Although these are still early days of the study, Some of these observations could potentially change our fundamental understanding of the early universe and how early stars were formed, because scientists have now found galaxies with a redshift of Z17. This is extremely rare and unexpected even to the scientists working on the James Webb Telescope. Interestingly, a lot of these faraway galaxies seem to have disk shapes, which are once again unexpected, as disc-shaped or spiral galaxies were believed to be formed only much later. One such example of these disc-shaped Z17 redshift galaxies is the Sears 1749 galaxy, which existed within the first 200 million years after the Big Bang. This is a big deal for scientists, because we didn't expect to see galaxies so old. Sears 1749 is extremely luminous for a galaxy that old, and also has an extremely high mass of approximately 5 billion suns, which is once again highly unusual for galaxies formed that early. Remember, most of these early galaxies didn't have more complex elements like our sun does today. They were only made up of hydrogen and helium, and were not supposed to have such a high mass. Up until now, scientists believe the first star showed up around 400 million years after the Big Bang. For the first few millions of years after the Big Bang, the entire universe was a thick soup of hydrogen atoms swimming in total blackness. This cosmic soup was so dense that the first light from the first stars in existence could not penetrate it. The hydrogen fog simply absorbed and scattered the starlight in circles, trapping the universe in what scientists call a cosmic dark age. Since light couldn't escape its surroundings during this period, trying to look back at this time with our telescopes would be like trying to see a light bulb through a thick, dark haze. This is the reason why we cannot see what happened right at the beginning of our universe, before the Dark Ages. Although everything was dark, this was a very special period in the age of our universe, because it is here that things transition from being very simple to very complex. Black holes, neutron stars, and complex elements such as oxygen and carbon, which are essential for life on Earth, had their roots in the fog of the cosmic dark ages. Scientists thought that the fog from this period did not lift until 400,000 years after the Big Bang happened. But to our surprise, the recent discoveries from the James Webb images suggest that the light from the earliest galaxies and star formations can still be seen, which could mean that galaxies started forming a lot earlier than we predicted, and the cosmic dark ages didn't last as long as we thought they did. Studying galaxies with high redshifts could help scientists answer what ended the cosmic dark ages and let the light penetrate the fog and pour out into the universe. If Sears 1749 is indeed confirmed to have a redshift of 17 after further research by scientists, we may have to change the fundamental framework of our universe's behavior just after the Big Bang. Right now, we follow the Lambda CDM model of the universe, which explains the behavior of the universe soon after the Big Bang. It has a cosmological constant and accounts for dark matter and dark energy produced in the early universe. It is the standard model of our universe which explains why the Big Bang happened, how we know the universe expands, at what rate the universe is expanding, and how long till it stops expanding, if it ever does. It even predicts the cosmic microwave background, which is the radiation left over from the formation of the earliest atoms, confirming the Big Bang theory. Up until now, the Lambda CDM model has worked perfectly for us. But these new galaxies with redshifts of Z greater than 13 might change our understanding and may even pose a threat to the existing model of the universe. With the abundance of highly redshifted galaxies that the James Webb Telescope is discovering each day, scientists are now even hoping to find galaxies with a redshift of up to 25, which can tell us about galaxies formed just 20 million years after the Big Bang. These galaxies are called cosmic babies. since they would have been the first to take birth in our universe. With all these new observations coming up, we might realize that the universe is actually older than we thought. Or we are going to find out that the beginning of the universe was a lot different than we thought. This was one of James Webb's missions, and it is, without a doubt, the most exciting time for astronomy in a very long time. However, these are still the initial stages of research. For the moment, nobody knows for sure the true redshifts of these objects. Everyone is now waiting for spectroscopic measurements of the redshifts, identifying how much individual lines in a galaxy's spectrum have been redshifted, rather than basing the redshift on the galaxy's color. This might take a few months, but this is an extraordinary period for astronomers, as they hope to see much closer to the Big Bang, maybe within 100 million years of it, all thanks to the James Webb Telescope.